Hi, this is Miss Head, and we're going to talk about today Unit 12.2 and 12.3, making inferences and comparing populations. When we talk about comparing populations, we are going to be talking about comparing data using a sample. Once a random sample of a population has been selected, and we talked about random samples yesterday, it can be used to make inferences or predictions about the population as a whole. Sometimes numerical results about the populations can often be obtained from the random sample using ratios or proportions instead of dot plots or box plots. There are 4 different ways that we can make inferences from data that we collect. One of them is making inferences from a dot plot. What would be the median number of motorcycle tire blowouts in a population of 400 motorcycles in a road race if this sample was of 20 motorcycles representing the whole population? So the 400 motorcycles in the race, these people have chosen 20 to represent all of them to see how many tire blowouts they can predict will happen in a road race. So the first thing we would do after we got our dot plot together would be to find the median, or the middle value in the sample of 20 data points. If I know that there are 20 points, I know the median will be between the 10th and 11th data point. The 10th and 11th data points, if you count, starting at 2 and counting over 10, you will find that they are on the same dot plot. So the median of the blowouts, the number of blowouts, would be 6, since 10 and 11 both are on the plot that's going up 6. So we can set up a proportion, and that's the second way that we can make inferences to find the median number of blowouts predicted for the 400 motorcycles. So the proportion would be the sample data of motorcycles, so that would be our 20, over all of the motorcycles, and that would equal our median of the sample predicted to have a blowout and the amount of blowouts for the motorcycles. It's a whole lot of words for just this little part. So let's take a look and see how we could do that when we set that up. So there's our words that we used again. The sample data, which if you look at that and you look at the first part of that proportion, you see the sample data of 20 over all of the motorcycles, which is 400. And we know that the median of the sample predicted to have the blowouts is 6, but we don't know how many blowouts are predicted for the whole amount. So we can cross multiply there, and we would get 20x is equal to 6 times 400, which would be 2,400. When I do my division by 20, I find out that x is 120. So 120 blowouts is the median number of blowouts predicted for that entire population. So in that road race of 400 motorcycles, it's predicted that 120 of those motorcycles will have a blowout during the race. Seems like a lot to me. A random sample, which is what they just did with the motorcycle, has a good chance of representing the entire population. So that means you need to make sure in a random sample that you don't just get like one kind of something or your friend. You want to get everything to represent it all. The bigger the sample, the better the inferences or predictions you can make about that population as a whole. Another way to represent data and to make inferences or predictions is the box plot. Now, in this example, There was a survey done of 7th graders, and they asked the girls and boys how many baseball caps that they own. So if you look to the left, you see the data that the girls had. Some of them had 8, 6, 4, 18, 3, 7, and more. And the boys, it looks to me like the boys had a little bit more just looking at the numbers. So in A, we are going to make a box plot for the number of baseball caps the girls own. Well, they put their numbers all in order. They found their median, and if you look, you can see that median is falling at 7. And they made their box plot. The lowest number was 3. The highest number looks to be 18 in the girls. And they drew their box, and they have their inner quartile there, so you can see the box there. They made a box plot for the number of baseball caps the boys owned. And the boys, on average, or the median, found that most of them owned at least 10 caps. If you look at the box with the inner quartile there, the box is your inner quartile, and you can see that it's a whole lot bigger than the girls. And it looks like the range of caps owned were started at 7, and some of them even went up to 18. So when we look and we compare the box plot for the boys had a lesser range but a greater inner quartile. You can tell that by seeing how big the box is and how short the whiskers or the lines are out from the box. And your inner quartile is that box. That's what you call the inner quartile, and we're looking at the range there. The middle 50% of caps was less spread out for the girls. That makes that box look like it's kind of squished in. It's a smaller box compared to the bigger box of the boys. The last way that a lot of people use data to compare or make inferences about a population is using finding the mean of the data that they're given. So in this problem, we have Paula and Daniel wanted to determine the average word length in 2 books. They took a random sample of 12 words each and counted the length of each word from each book. So in book 1, there's a box there that represents all of the word lengths. And in book 2, we've got the word lengths of it in the second box. So the first step you would do would be to calculate the mean of the first book. So you would take all of those pages and add them all together. So you'd have 3 plus 7 plus 5 plus 2 plus 4 plus 3 plus 1 plus 6 plus 4 plus 8 plus 2 plus 3. And since there are 12 numbers there, we would divide all of that by 12. So when we add that together, we find that we get 48 over 12. So our mean average for the length of words in book 1 would be 4. 4 letters long. So if we looked at the range of the number of letters and words, our biggest number is an 8. Our smallest number is a 1. So we would subtract the largest word length from the smaller ones, and we would get how long the words would be in between that. Now, we've done it for book 1, so we will do this again for book 2. We find the mean of the book word lengths in book 2. So we add all the data together again, and again they used 12 words that they counted how many letters were in the words. They added all of that across and divided by 12. Well, Book 2, when you added all of those words together, the letters of those words, you got 48, and it's divided by 12. So the mean for book 2 is 4 letters long as well as it was for book 1. So when we find the range for book 2, the range is going to be different than book 1. It's a smaller amount because we would subtract the least word length from the greatest word length, so that would be 6 minus 2. The longest word in book 2 was 6 letters. The shortest was 2, and when we do that, we get 4. And that's another way that you can make predictions and comparing data that you want to present your findings on. So, that's a whole lot of information in a very short amount of time. But now you need to scroll down, answer the questions, and press submit. That's your responsibility. And this is Miss Head, and you all have a nice evening. Thank you.